We're live. Welcome, guys. We have another amazing live stream today with our founder, Shashank, and Mr. Greg Osuri, founder of Akash Network. Welcome.
Great to be here.
Yeah. Hey,
Thank
Greg, nice to have
you
you
for having
here.
me. Awesome.
Yeah, we can probably start from like learning a bit more about Akash, how you got started in crypto, and also how what was your inspiration behind building Akash, because it was before the AI wave and before anyone started focusing on compute as much. Yeah, so happy to learn that.
Boy, where do I start? Let's see. I feel like my life story is so entangled with the founding of Akash. Um, I, growing up in India, I had to rely in the '90s. Had to rely on a lot of open source technologies to really get ahead in life, and I, for one, became a big advocate for open source because I want to see the benefits that I was able to get out of it spread more, right? So I've been programming since I was a kid. In the '90s, didn't have my own computer, yada, yada, yada. The real turning point was when I built an open source Java server, I believe in early 2000s. 2002, 2003 timeframe that got me an opportunity to come to the United States, and I became I became a major contributor to a lot of open source software. I In 2013 I was heavily focused on container native infrastructure because until about then infrastructure was very brittle in the sense that running on virtual machines were the trend, but then these machines are extremely mutable, so anything could go wrong in these machines, and it wasn't very consistency was very hard to achieve between environments, right? So you would build one thing in your local environment. By the time you see that in production, it'll be something different. So a new technology wave called containerization was kind of taking stage, and it got
Docker and others.
what's that? Docker was
Docker, yeah.
Docker came a little later, but I was focused on LXC, which was a native Linux containerization framework. Docker came in. LXC was very hard to use. Docker came and made it super simple to use. And containers didn't really have orchestration or fault tolerance. This is before Kubernetes and before Terraform. And I was working on Terraform as a developer, and I, through several people, I came into Kubernetes. This is before Kubernetes launched. I saw a demo by one of the creators of Kubernetes, and I thought this was something that I could spend my time on. That's I wrote a bunch of libraries. You can see my GitHub; they're still very active. This is way before, anything agentic coding, right? So it's still reading hand libraries. They're still very, very useful. A lot of even Kubernetes and Helm and all those still use my libraries. I noticed a trend where while a lot of us, benefit from open source, and a lot of us have this values of contributing back to open source, not only because the right thing to do, but because we believe, a lot of us in the open source community believe collective intelligence is better than the opposite, in the sense when more people look into a single problem collectively, with the only motivation of making the software better for everyone else, we just have good software like Linux and Kubernetes and Docker and all this amazing open source software, right? That's the ethos. And we noticed the world was increasingly going in the opposite direction. In the sense, cloud was getting extremely powerful and extremely important in a lot of our everyday lives. And Amazon seemed to be unstoppable for all intents and purposes, and we had a resurgence of closed source software, particularly in Amazon's case, where Amazon would take open source software and would offer hosting services on their open source software and effectively kill any business models these companies would have, and became a giant rent seeker, right?
Yep.
And that was disturbing for a lot of us in the open source community as well as the academic community. And the idea that total cost of ownership is going to be lower on the cloud was just a fallacy. Even though it looked like, from a unit economic standpoint, it's the most optimal thing to do to move to a shared system instead of having your own dedicated system. But you end up just using a lot of other shared services, and your total cost will actually go up. And so many cases where you could see the S1 filings, means filings that companies do before going IPO. You would see a lot of these financials of a lot of SaaS companies. On an average, about 50%, every half of every dollar you pay was going to a cloud provider for the services. And in some cases, like Asana and whatnot, about 60 to 70% would go to a cloud provider. And Netflix, I think like Netflix was 70% was going to cloud providers because of all compute, right? And a lot of this was, rent seeking, and the margins were 60, 70% for these cloud providers. So that's when it really clicked to us. If cloud is going to be so ingrained in all our lives, and everything we do is going to be on the cloud, the access to the cloud should be open, and the software that governs the cloud should be open. It should be built by the people that use it. That was our vision that we began with. This is way before Akash, or way before we formalized into a system. So we started working on open source systems, right? So Cornell came up with the idea of SuperCloud in 2015, I believe. And we were working on a system to, we're not necessarily going open source, but we were working on a system to aggregate cloud resources. Because when cloud came into research into its ascension, there were a lot of data centers that were still very, very good, and had a lot of compute that was unused. And the idea was, well, if we can aggregate this compute and build a cloud-like layer on top of it using technologies like containerization, and because containers will let you move from different providers very easily, using technologies of such sorts, you could achieve a functional cloud. And there are a lot of efforts everywhere, multi-cloud and a whole lot of things. And we found the Cornell's approach of a supercloud, where you decouple the control plane from the resource plane, and can achieve a fairly distributed cloud. And we took some of the ideas from the supercloud concept and built the first ever supercloud that is functional, the Akash network. We wrote the paper in and we were experimenting with a lot of decentralization at that point. I mean, this is 2015, 2016 timeframe. I think someone at the Go conference, and I was, into Bitcoin, and as a user, not as a developer, I was just fascinated by the blockchain. As an engineer, the fascination came from me because of public rights. Like as an engineer, up until then, my understanding was every database needs to be private rights. That means you need to lock in the rights for a database, right? The writability of a database, and you can open the readability, right? Anybody can query a database publicly, but there was no concept of a publicly writable database. This just doesn't exist. And it was fascinating for me because if you build distributed systems, your biggest challenge is, bootstrapping credentials in the big. So I was working for a lot of startups back then in San Francisco, a lot of high scale startups. I was working for this company called Demand Base, which was doing about 1 billion. It was, I was in ads for quite a long time. I was doing 1 billion transactions a day, and I was responsible for the infrastructure. So we would run thousands of servers across the world, low latency. I mean, the goal was to achieve sub 50 millisecond latency, because ads need to be served fast, right? You don't want a slow ad. This actual money, you can measure by the latency and how much money you lose. So I was developing high performance, highly reliable systems, and always the biggest challenge is how do you bootstrap a system that's remote? You don't know, you don't necessarily have a good trust envelope for the system, and how do you really exchange credentials? Who gets the call, right? It's very, very challenging even now. And here comes a distributed system called Bitcoin, where anybody can write to it. There's no credentials. It's all like credentials are created locally. I mean, that was fascinating, right? So it was a very simple system, XTO and all that. The only thing you could do is a ledger, slow, but it made sense. Then Ethereum came and said, well, look, you can make that system programmable. And that was fascinating for us. Deterministic, but still programmable. Determinism has its own set of challenges when it comes to general purpose programmability. And so it was very fascinating for us. And we started on Ethereum, and Ethereum didn't quite work out because CryptoKitties launched. This was a time when the biggest innovative app was OpenBazaar. I don't know if people know about it, but that kind of didn't work. I mean, if you try to use OpenBazaar, you would have to download the entire ledger, and that would take like 10 hours. And it was very early stages. And I also had really good friends like Stefan Thomas, who was the CTO of Ripple back then. I mean, this was San Francisco. How AI is right now in San Francisco was like crypto back then. Everybody was doing AI, crypto. There's also this famous New York Times article that said everybody's making money and you're not. Something with Ingel was twins, I think. It was a crazy time, and we saw the Filecoin, and then Filecoin around the same time Filecoin was being created. White paper was fascinating. Really like it, and we thought this was a good time to release a paper and see what people think about it. We released the paper, and the reaction was incredible. We were the first one to even propose something called a decentralized cloud. Back then, it was all about smart contracts, all about DeFi wasn't even a concept yet. It was mostly smart contracts. Oracles were not even a concept yet. It was a lot about proof of stake. It was moving from proof of work to proof of stake, and all about new consensus mechanisms and all that. So decentralized cloud was not even a thing that people would even comprehend or understand. So the idea was exciting for a few people, and a few people that found it exciting. We raised like a small round, like $1 million, $1.5 million, something like that, small one, to go and build out the chain and prove out this actually works. And we launched in 2020, and it worked really well. GPUs were on part of the roadmap. In fact, when we started Akash, one of the big use cases were we were looking at what are some of the industries that would benefit the most out of this low cost, underutilized supply, and AI was a clear winner. And our early customers were all AI customers, and without GPUs, even CPUs, because AI had other data challenges, bandwidth challenges to move data, for example, from sensors to the cloud system is very, very expensive. Very expensive to just move data. So a lot of challenges. AI was obviously our biggest vertical that we were focused on, and talking to a lot of AI folks, it was very clear that GPUs were getting very scarce. This is in 2020, right? Then we put GPUs on the roadmap, and it became very obvious for us GPUs are going to be the biggest drivers. It was very hard to get GPUs in a fully distributed, decentralized way. And then ChatGPT came in 2023, it blew up, and we blew up, and the rest is history. So that's really how we got GPUs on the blockchain. And then after we launched, there was a lot of people that took the idea, and you see a million GPU marketplaces today. We see other patterns now, similar patterns, like when we said GPUs are going to be scarce. We also called out energy scarcity, right? So energy is going to be scarce, and now we're seeing Elon Musk going on stage and going on podcasts talking about energy. I testified before Congress about energy, last year, and so it's quite a lot of, like, we're seeing similar trends, but I feel like every resource that AI touches is getting scarce right now. So a lot of opportunity. That's the origin story.
Yeah, thanks for the detailed story. And so how many GPUs are there on Akash network right now?
I think not too many. I don't know the actual count, not top of my head. Not too many though. We have a lot of CPUs. GPUs come and go. There's a huge demand right now for GPUs. It's like it's very hard to even get H100s anymore. So it's a very interesting marketplace, right? So there's quite a lot of stuff we need to do on being able to. It's almost like the winds have shifted from people individually getting individual GPUs to like taking large quantities of GPUs. So we're now in the process of refactoring our marketplace to support large orders and not individual orders. Large orders in the sense like, I would say like 50 to 100 nodes, each node having 8 H100 type nodes, right? Because of the volatility in the market and unexpectedness of the market, people are leaning towards long-term contracts versus on-demand type style deployments, right? A lot of the on-demand deployments have moved to inference for the most part, in the sense like if someone is just wants to, a lot of the on-demand was like, hey, I want to host a model, right? That's really what the demand was. Or maybe here and there you'll have some fine-tuning customers, but not really. That has subdued quite a bit because the models are, getting extremely good, especially open source models, and people are having their own harnesses and doing all kinds of things that are delivering incredible results. So we're seeing a shift in market from traditional like indie devs, because Akash really was, from a GPU standpoint, focused on indie devs and like focused on like the smaller developers, to large enterprises, because a lot of these companies are making a lot of money and the needs change. So we're right now in the process of redesigning a marketplace to support large orders that's time bound instead of open bound, right? So the demand for, the supply chain we have right now, in the sense GPUs waiting to be coming online, runs about 10 to 15,000, I think we have. But these providers are not, and both providers and tenants are looking for consistency and some degree of availability guarantees, in the sense like, hey, I'm going to pay $2 for H100. I want this price to be locked in for the next 2 years.
Okay.
Because the volatility is so high, right? So after we implement this new marketplace design, we should have few 15 to 20,000 GPUs on it.
Nice. So is your focus more on GPUs available with data centers and using their spare capacity on Akash, or are you also targeting GPUs that are with retail, like 4090s with gamers? Like which one? I believe the ones with data centers are more your targets right now.
Yeah. So if you look at Akash's incentive mechanism, right? We incentivized mostly enterprise GPUs. We did not incentivize home GPUs, and we did something called pips, or we call them pilots, right? So we said, well, I think that's one of the best things we did, because we, there's a lot of like deep, quote unquote, deep networks that came about and just incentivized left and right for all kinds of GPUs. And we noticed, according to them, talking to them, only about 1% to 2% were actually real. Or not real, I would say, like with a degree of quality that's acceptable.
Yep.
Because it's very hard to determine quality, in a distributed environment. So,
and also,
yeah,
and I guess reliability would also be an issue, because if it's retail customers, it's difficult to ensure that their GPUs have that uptime that's required by enterprises.
Correct. Reliability, uptime, security, a whole lot of aspects of like, that prevent enterprises from using a distributed system or a decentralized system, right? So solving that was very, I mean, we're also developing a comprehensive suite to solve the reliability issues. It's not like provision time reliability, but it's continuous reliability. That's more important. How do you ensure? It's very challenging because, you can get to technicals, but the biggest challenge is if there's a workload that's running, and if you have to measure reliability of the system, you cannot stop the workload from running. So doing it real time is very challenging. I don't think anybody has a good answer on how to do this. And second, so because enterprise wanted enterprise grade GPUs, we went to data centers, and we said the pips are going to be pips are like pilots, right? As the name suggests, it's going to be pilots, so we can understand how these companies are using them, or how the reliability and whatnot. And we were able to get pretty good reliable GPUs. Venice was a big user. So News Research, which developed Hermes Agent, is a big user. Astria, a lot of customers that were pretty good users. Our utilization rate is about 70%, which is very happy. We're happy with it. But now with the energy crisis, data center GPUs are no longer the only source we can tap into, because the data center space now is so hard to get in America or in the West. Anyone that's deploying meaningful AI will tell you how hard it is to get data center compute. Energy is getting extremely challenging, right? The most challenging aspect. Now, distributed training and distributed inference are getting good to a point. Is actually we can consider home computers, 5090s and 4090s, as a potential source of GPUs. Now, considering we solve the reliability problem, or at least we can't solve physics, right? I mean, there's just physics, right? A home computer is a home computer. There's a lot of challenges to get your home computer, being bandwidth and whatnot. But we have a framework for fault tolerance. I'm not saying fault avoidance, because that's impossible. Fault tolerance, where a lot of the AI jobs are asynchronous in nature, meaning we can do very intelligent routing, intelligent, handover in terms of reclamation. If a node sitting in a home has to go offline, reclaim its resources for whatever reasons, how would that look like in terms of failover for a workload, right? Security-wise, a lot of home computers now, at least a lot of AMDs or ARM and not Intel, sadly, have very good support for trusted execution environments. Each have their own mechanisms, so you can reliably run quite a lot of privacy optimized workloads in these in these computers. So there's quite a lot of work we need to do in terms of cohesive framework for fault tolerance privacy. And we announced Home Node as recently as this program to attract more compute nodes that are in the home, that are 4090s and 5090s. So we're going to see a big, and we have an enterprise partner we're rolling out with. We'll be making that announcement very soon. So we have a huge, rollout plan for home computers. So you'll see 4090s and 5090s. So again, a market for 4090s and 5090s are is mostly diffusion market, right? So it's not as mature as your LLM markets. So let's see, we're not very, and the state of distributed training is not yet there in terms of maturity to be I would say business ready, but it's getting there. So a lot of trends are showing. So when that happens, we want to be the first. We want to be the platform to take advantage of distributed training.
Oh, nice. Yeah, I guess one of the advantages with data centers is also internode connectivity, because most models, both for training as well as inference, you would need multiple nodes at a time, and you want to transfer data across nodes between memory and GPU. So it's faster when
For now, that's the thing, right? That's the challenge, and there's quite a lot of work happening in. If you look at work from Pluralis, look at work from Jensen, look at work, well, I guess Google DeepMind made a Dialoco from that open Dialoco from Prime Intellect. There's quite a lot of frameworks that are popping out there that can make distributed training a reality across heterogeneous GPUs. So yes, right now the big challenge is bandwidth, right, between nodes, between memory and GPUs, inter GPUs. NVLink gives 3.2 terabits per second TBPS. That's hard to match over a distributed network, right? So it's quite a lot of challenges, but the algorithms are evolving to a point. I think it seems promising, right? And we saw another maybe tensor subnet. I think it's no longer sub. I'm not sure what's the drama there, but they trained a 72 billion parameter model, which is better than Llama 70B. Llama 70 billion parameter model is considered to be a very useful model, right? We use Llama 70B. I use Llama 70B in my home.
Oh, nice.
My local GPUs. So it's a very good model. I mean, so there are a lot of models that are trained distributed in a fully distributed manner. That I believe will achieve SOTA in like 2 to 3 years. It's not there yet.
And also, I guess you answered it previously, but is most of the load on Akash is it training or inference?
Inference,
yeah. I mean, that checks out, because like with agentic workflows, it's been more about building good workflows, good harnesses around agents, and you can get really good performance out of existing models rather than retraining models from scratch, because then you lose a bit of generalization. It takes a long time, and it's not for everyone to be able to like fine-tune models in a stabilized manner. So yeah, kind of checks out there. Can you tell a bit about home node? So if anyone wants to participate in that, like what do they have to do?
It's very simple, actually. I mean, so it can be a Windows machine or a Linux machine. You just download a installer and just run it. It's very smooth. It's optimized for a non-technical person. From a technical, I mean, it does require you to give up your computer for the amount of time that is being consumed, because you can't really check GPUs. But if you have a 5090 at home, you have a gaming rig. Most gaming rigs run Windows, right? You have a gaming rig, you just download it, install it, and while you're not using your gaming rig, be it during the night or whatnot, or when you're at work, you're not using the gaming rig, it'll contribute to your to Akash, and you earn in dollars when it gets used. And you come back, it just and you can reclaim it very easily for you to replay your games, whatnot. I said the reclamation, the handover process is very key for a home computer, because people are using these machines to play games, right? So that's where so the workload, for example, if you're AI, if you're training or something, or if you're running some inference, inferences are not usually more than a minute, 30 second a minute, right? So if someone wants to, if you're a computer provider, if you want to reclaim, you hit a reclaim button. There's some time window you're supposed to allow for reclamation, say like 10 minutes. And the idea is the tenant who's using your your machine has about 10 minutes to offload and move to another machine. All that is programmatic. It's not, it's not humanly sitting there and like reclaiming, right? All that can be done programmatically. And you move to another workload. So that way you are, as a tenant, you're not having interruptions. And as a provider, you can still reclaim your machine and still use it for what you want to use it for. So the handover process is very, very important for home computers.
Oh, nice. Okay, so most people that we have had here, usually their story starts with discovering Bitcoin at some point, or discovering ETH, and then they got into crypto, and then they decided to build something. In your case, it's been more like having a systems background, distributed computing, containerization, and then finally getting into crypto through the tech and trying to solve a problem that you were interested in by making use of crypto as a coordination mechanism. So people who don't know much about crypto and are only in AI, how would you, if you had to tell them the value crypto adds to AI, like how would you go about explaining that?
That's a broad question because I talked to a lot of AI folks, and a lot of them don't. I mean, it really depends. I wouldn't say AI is a particular entry point, but it really comes down to what ethos and what values people have, right? I've noticed personally, a lot of AI folks are, maybe it's the age, maybe it's the, it's a new world. People seem to, a lot of them are very young, in 20s usually, and they don't have the same ethos for open source like people like our age group. I'm mid 40s, so you almost have to, when you don't have shared values, right? So you almost have to look at what people value and approach from there. Now, monetarily, is there a monetary value from crypto to AI? I don't know. It's quite hard to tell. I don't try to convince AI people to use crypto. Honestly, I gave up doing that. I took so many punches. I don't want to take more punches trying to present crypto to AI. There are a lot of other challenges too, right? It's not just technology problem. It's also a brand problem. Like for me, a good use case, when I talk to AI folks, it's not about crypto, it's about privacy, right? So for me, I run GPUs at home. All my data that gets generated in my home, like camera feeds to sensor feeds to audio feeds and whatnot, go into the local GPUs. It doesn't touch the cloud because I like privacy, and I don't want my private intimate data to be on the cloud because anything that leaves your network is vulnerable, and you can't really trust anyone with your data except yourself. That's what I truly believe in. And a lot of people don't even share the values,
But why would you say the attitude towards open source is different from the people who are currently in 20s versus like us at that age?
Because there was no struggle, right? You didn't see Linux getting into what it is today. When you have to use, you didn't see the wars. I mean, I was able to witness Linux growth, right? And the struggle from open communities. Today everything is kind of free, right? And you don't really pay for Mac OS or Windows. You don't think about operating systems. You don't think about open source or closed source. You just use it. Either it's free and either it's like monetized using attention or monetized somewhere else. But before, you don't even realize how you're being monetized, So there's a lot of like facade on what technology, the underneath technology, everything's free. Like you use TikTok, you use social media, you use pretty much everything is free, right? Like it's fine. Like you got to take a monetary approach. I think or a privacy approach, right? So I think what people will be moved on is like, hey, would you want your models to be? I think now when using cloud code, it's very expensive, right? A lot of people are paying a lot of money. And the angle should be like, shouldn't this be cheaper or free? Like, what happens when the Chinese labs stop producing state-of-the-art open source models, right? Then how do you get your models? Well, you can get it from cloud or OpenAI, but then you end up paying a lot of money. So I think it will come a time when decentralization becomes very, very important. And now I was at ICML last year. I gave a talk about training and distributed training becoming a real thing. Because if you have to rely on these companies to give us intelligence, then we lost as a society. And that message seemed to resonate quite well with a lot of folks in AI. Because economics, right? Like, okay, you can get access to GPUs at the scale that OpenAI and Anthropic can. What do you do when you want to train models? So I think that monetary aspect makes it a lot more easier. Now, as algorithms get better and better in terms of being able to distributed networks, that becomes a case for AI. So I think distributed training is a good way to convince AI people, and it has convinced a lot of AI people to look at crypto more aggressively. I almost want to say metaverse because I think it's a dead idea, but I think it can make it come back, especially with agents. How do you? I mean, is there a world where agents and humans interact like in a virtual world freely, right? So I think that's another place where AI folks would be interested in crypto. But also crypto has a massive brand problem, like a lot of scams and a lot of greed that has taken over crypto. So it's almost like if you go to Akash's website, we don't talk about crypto. We haven't talked about crypto in a long time. We don't mention any crypto terms. We have other products like Akash ML and whatnot. There's no mention. We had to build new products just to even get away from crypto branding because crypto has a really, really big brand problem with AI.
So, do you call it decentralization or like privacy focused, or like how do you go around it then?
Whatever I go by the use case more than like crypto does all this stuff. I go by privacy, right, or distributed training. I don't even call it decentralized training. In the word decentralization, I think has like tainted pretty badly.
Yeah, negative connotations.
Yeah, so I would go distributed training. It's easily understood now. Of course, what you use underneath is decentralized. Like Akash ML, for example. I mean, Akash ML is doing fairly well, right? We're doing, I don't know. I think we're doing about 100 billion tokens a month now, which is not nothing. We're processing about 100 billion tokens a month. I think we're doing more tokens than on OpenRouter than Cloudflare and whatnot, which is pretty decent volume. And nobody that uses Akash ML knows we're using crypto on the underneath rails. So you almost have to like, if you're trying to sell to AI people, don't put crypto in front. You'll never be able to. Trust me. I agree with that. We lost such major deals because we mandated crypto purchases. I'll be very open at this point. I think like, I don't know where the NDAs stand, but I mean, I don't want to name the company, but it's a very big company and everybody knows this company. Not even AI. I mean, everybody knows this company. We forced them to buy AKT to use Akash, and that went up the chain. To the finance department, and the finance department was very unhappy with owning crypto because large companies don't. It's not like your credit cards, right? They have people, and they don't want to touch crypto because of the risk profile. And then we have to go through all kinds of stress, and you eventually lost the deal because of crypto. So if you're trying to sell to anyone decent in AI, don't do crypto. Trust me, it doesn't work. And I think trying to force crypto on people, on AI people, was our biggest mistake we made, in terms of even providers. No provider wants to touch crypto. Like nobody. I don't know. That's just a really bad brand name for crypto. And it's getting worse. It's not getting better.
Yeah.
Especially with like a lot of political involvement now. That's never good for anybody. Nobody likes to be involved with an industry that's heavily politicized on one side. It should be a non-partisan thing. That's also impacting quite a lot for crypto AI now. So crypto now.
Yeah, I mean, I do spend a sizable time in SF, and it's not a good idea to tell them you work in crypto there. Like, just it's better to say, okay, we do this in AI, and it's better if you want to work with enterprises there, because otherwise it's just difficult. By the way, do you use those Mac boxes in your network as well? Because they seem to have large continuous memory, which is good for some kind of models.
We don't currently, but I am playing with them.
Okay.
This is very promising. Yeah, 96 gigabits of unified memory is very attractive, right? I mean, you're able to run. I haven't run anything. I have a Mac Studio right now, in M1, I believe, or M2. I can't. I have an M2 Ultra, which is pretty good. I could run some models here. Maybe I should. Yeah.
Yeah, I mean, it's difficult to get them anywhere. Like they've been sold out for a long time. So
Mac Studios, Mac Minis.
Both actually. Any kind of Apple boxes, it's just difficult to get them there. Like when the OpenClaw grew, they kind of just got sold off the shelf everywhere. So it's difficult to find them anywhere.
Yeah, they're good machines. I like them.
Yeah, I agree there. Okay, so let's talk a bit about agents. How do you think the agents will grow, like specifically in crypto? Because I think it's a consensus that internet is going to be run mostly by agents. They're going to be the ones making most transactions, sharing data, and then so on. So, like, what's your take on agents doing transactions on chain?
I share the sentiment that agents will save crypto or destroy crypto. I don't know. I think agents will use crypto quite a lot. Because crypto traditionally has a very challenging user experience. And after all these years, I've been full-time crypto for almost 9 years now. And UX has been the conversation from day one. And the fact that we are unable to achieve UX even now, I'm talking not about 2,000 people that use DeFi. No, I don't care. I'm talking about the billion people using crypto. We're not there. We're not even close to being there. So I feel like agents, because there's so much, I guess, poorly designed crypto onboarding. I mean, guilty as charged. I'm not saying Akash itself. Even Akash doesn't have a good UX. I mean, I'll be fully frank with you, because it's very hard to achieve like non-custodial experience and have a good UX. Akash ML, on the other hand, is incredible. It's amazing. I mean, the UX on Akash ML is just, it's very obvious we have such incredible growth, right? Because we don't touch crypto. The moment you put a key, everything just changes, right? And your entire interaction with the app changes completely. I think that's where agents will not. Well, there'll be a problem for humans, but agents will not see that as a problem. So putting an agent on top of a crypto app is obvious answer, right? And also there's a lot of reasons why you want the agents to be using, like, you want to get hosting in Akash's example alone. An agent is not going to go to open an Amazon account to go through verification. I don't know last time when you open an Amazon account, but it's not the easiest thing in the world. setting up an AWS account or GCP account. Oh, it's even horrible, right? Azure. Oh my God! Like, don't even think about it. Like, so expecting an agent to go set that up is not real. Well, can agent go use Akash right now? Easily. A lot of agents use Akash now, right? Easily. Like, you need to create a key, and there's an MCP server. You can discover all the endpoints. There's a command line which you can go and figure out all the commands. It's very straightforward. It doesn't need to talk to a human being. It doesn't need to talk to anyone. As long as it has tokens. There are lots of ways you can get tokens. And even getting tokens is also, is fairly easy, right? There's a lot of dexes, a lot of decentralized exchanges, a lot of ways you can get tokens. Agent can figure that out. Agent has figured out how to use Akash in a matter of minutes. So agents, if you're given a choice between a fully tight, centralized, non-bot friendly user interface, a lot of them have bot protection too. Like, you go to Amazon, they're not. If you're a bot, they won't even let you touch the website, right? I mean, it's a lot of bot protections, right? And constantly trying. Even Akash, like we have now, username and password. We have to put so much bot protection because the abuse is out of control. The moment you have credit cards for a crypto product, I don't know how many people have that, but oh my God, the Stripe abuses we get is just, I haven't seen anything like that. Anything you do, people will figure out how to abuse it. Internet will figure out how to abuse it in crypto. The amount of fraud, the amount of, it's not even regular people trying to hack. These are state actor sponsors, right? Like, we're in talks with a lot of law enforcement a lot of times, and the last FBI is very clear that, hey, we got one of our test servers got abused by North Korean actors, and we get that a lot in crypto, right? So it's unfortunate that we have so much abuse. So we have to put protections against abuse, and that unfortunately prevents bots or agents from using the system. So, but if you do crypto, we have very little abuse using crypto. Credit cards are notorious for abuse, right? And every time there's an abuse report, we got to give the money back. So we eat the cost. We, in the sense of Overclock Labs, the incorporation eats the cost. I almost hate using credit cards so much, but we have to have credit cards, or else we won't get customers. So, a part of me thinks like, okay, the version of the Akash Network console where there are no credit cards and just all self-custodial, incredible. Go use it for AIs, right? I almost want to decouple these applications. I want to build credit card only applications for humans and private key only application for agents. I almost want to decouple now, because just optimize the experience for agents and optimize the experience for humans. That seems to be a viable path that I want to take.
I think every website would want to go that way because even if there's no crypto involved, the optimal UI for an agent is totally different from optimal UI for a human. We need all those images, boxes, like a lot of things to click, whereas agents would be happy with a command line interface.
So ask yourselves a question, right? I don't know how many apps you have experience with, or e-commerce or not. If you remove bot protection for a credit card driven website, ask yourself the amount of fraud you're going to get. It's impossible to deal with it. So what do you do when you remove bot protection? You got to go crypto. There's no way in hell. I'm going to challenge people to remove bot protection if you're accepting credit cards, and see what happens in terms of fraud. So I think that's a strong case for crypto. I'm not talking about wallets that give you like, hey, onboarding crypto from real world. No. I'm just talking about pure smart contracts, pure that are unapologetically crypto. I'm talking about like open bazaar style crypto. Nothing, no logins, no emails, no password, none of that stuff. Even emails. The moment you have emails, even the SMTP server open, they'll get abused. Trust me.
Mhm.
Like it's just people will figure out a way to abuse it. So I'm talking about pure crypto rails. Like peer-to-peer messaging using crypto rails, everything crypto. I think that's the only way for agents to use it.
Yeah, I think I'm gonna use that argument next time whenever someone asks why crypto rails are the best for using agents. I'll be like, yeah, just turn off your bot
Try
protection.
removing bot protection and try running agents. Yeah.
Good argument. Okay, we're almost out of time, so let's quickly move on to our next next slot.
Yeah, we have the rapid fire questions. So all the questions are AI, aside from the first one that is a little bit personal, laid back. So here it goes. So between coffee, matcha, Red Bull, which one did you have this morning and how many cups for both of you?
Coffee. I mean, everything else is crap.
Yeah, coffee, of course.
How many cups, if you want to be honest?
One.
Oh, that's good.
In the morning, one, but yeah, throughout the day, a bit more.
All right.
I drink about 2 a day. I don't exceed 2.
Okay.
Okay, so this is for you, Greg. Which is more underutilized globally, GPUs, energy, or human brain power?
I would say human brain power for sure, but more practically, I think energy. I mean, we have a gigantic nuclear reactor in the sky called the sun. I don't understand. I understand why, but it just doesn't make sense to me that we don't use most of it. Like most of it goes to waste. And while we are building such infrastructure to compensate for our lack of motivation to use sun's energy. I'm a big proponent of renewables. I'm also a big proponent of distributed. I mean, my testimony before Congress was about leveraging renewables to train AI. So yeah, I think energy is severely underutilized.
I would agree with that, but would also talk about nuclear a bit because even when we talk about renewables, like nuclear energy is one of the cleanest forms of energy, but a lot of countries in Europe are kind of like against nuclear because it seems dangerous. But like it's just cleaner. It's better. I mean, you have to have a lot of things in place, security measures to ensure there's no accidents and everything is secure. But like personally, I'm a huge proponent of nuclear energy.
No, I like nuclear. The only problem with nuclear is it took about 14 years to build a nuclear reactor in America. We have about 96 reactors in America. Kind of dumb that Europe just went anti-nuclear, and it's one of the worst decisions they made. I'm very pro-nuclear, but at a macro level, there's a limited set of fuel, right? There's a fixed cap on nuclear fuel and the supply chain is extremely challenging. I spent a lot of time studying this. So it's not. I mean, yeah, I'm big pro-nuclear, but I'm also like big pro we have this free energy. You don't need to go through all that stuff. The only thing, the challenge with solar is non-continuous power, right? The challenge with solar is storage and transmission. I guess transmission is the problem. Doesn't matter if you're nuclear or whatnot, but particularly in renewables, because our grid is not designed to be peer-to-peer, or it's designed to be hub and spoke. That means you generate energy in one place and you can distribute the energy. It's never designed to generate energy at the edge and distribute back to the grid. That is a challenge in nuclear. It's not. In a lot of ways, you can do storage. I mean, there's physics-based storage where you can just have big stones and whatnot, right? There's a lot of new innovative storage mechanisms now. But transmitting the energy, like for example, if I produce energy at home and transmitting that energy to a storage facility for solar is very, very hard. And that is the problem. It's not the technology per se, but a lot of supply chain and storage and transmission.
Yeah, I mean, kind of goes against the grain. The way the grid has worked for so long, like if you try to do something which doesn't align with the current system, then it's difficult to do because you have to kind of change everything.
It's impossible. I mean, especially in West, where you have very strong property rights, and like you can't
Yeah.
just put new lines or replace existing lines without people going up in arms.
Mhm.
I mean, it's physics. It's a copper wire. There's only so much limit a copper wire can transmit in terms of energy. It's a physical limit, right? So you can't really do much about it. And more distance you have, bigger wires you need
Yep.
because there's always loss in transmission, and or else you need transformers, and there's a lot of it's a mess.
Yeah.
All right. So the next one is for our founder, Shashank. What's one human trait or human instinct we shouldn't pass to AI agents?
We shouldn't, or like
We
what?
shouldn't.
Oh, laziness. Just just do my work. Don't be lazy. Don't be like chilling all the time. Just do what I'm asking you to do.
Yeah, I think that's built in. All right. This is for you both. And this is also about energy. So, what do you think about the free energy dispute between JP Morgan and Nikola Tesla? I'm joking. I'm joking. Does AI have a compute problem or an energy problem?
Has both. I mean, right now it's energy, um, but compute is. I mean, data compute. There's a lot of problems, right? I mean, like Jensen says, like 5 different layers, right, of AI. I think AI is just not one thing. I mean, you got to look at every angle. I mean, energy is right now a huge problem. I mean, it's very obvious, right? It's not. I mean, when I was talking about energy, it was not very obvious, but I mean, I was talking in terms of predictable predictions. But right now, I mean, we are trying to get data centers, and there are a lot of data centers that are being rotating. I mean, basically, if you have some data center space, you can't build new data centers anymore.
Mhm.
Because of energy challenges. So people are rotating quite a lot. It's very, very hard to get anything beyond about 100 megawatts right now in terms of data centers. I mean, smaller data centers are a lot more easier because they're mostly inference scale, but training scale is impossible because of energy. I think right now energy is a big limitation, and but will that be solved? I don't know. I don't. Energy markets or industry doesn't move as fast as your technology industry,
Mhm.
right? Like chips, for example. In 2023, Nvidia sorry, 24 made about 500 H100s. In 25, they made about 500,000 H100s. 25, and they made about 2 million H100s. So they literally quadruple their supply chain, right? Energy doesn't work that way. Like there is
Yeah.
a 4-year lead time for transformers right now, like 4 years, and about a 14-year lead time for generators, the turbines and generators. So 14 years, right? We're not even talking about renewables. We're talking about LNG because that seems to be the only viable path, right? In terms of what you can, and the worst thing that we can think about is going back to coal, because even that needs that needs turbines too. So it's very, very hard to scale energy than scaling. I mean, Elon was so pissed off that I mean, if anyone that knows how to scale energy would be Elon Musk, right? Because he built massive data centers. He was so mad that he wants to abandon Earth and go to space for energy, right? You saw about space data centers now getting very
Yeah.
popular. They wouldn't be popular if you had energy on Earth. So they literally because in space you have near continuous power for solar, right? And you can follow the sun, you can always be on the sunny side. You don't need batteries. Uh, economics don't make sense yet, but they're starting to make sense, right? As cheap space gets cheaper and cheaper. But in like 3 to 4 years, maybe in 5 years, you can see space data centers becoming a real thing if energy is not solved on Earth.
Maybe a silly question, but how would the heat dissipation work? In space?
Radiators, they're large radiators, and they figure out that problem. That's not the problem. Economics is the problem. Right? Yeah.
All right. Another one for both. If you had to steal one founder to be your sidekick for 24 hours, which one would you choose? From the list is Vitalik, Ilya from Near Protocol, or Jesse Pollack, the founder of Base.
Some of them are friends, so I can't say. Um, uh, for 24 hours, I have a lot of questions for Vitalik. I would pick his brain, maybe solve some of the problems that I have that we're working on.
All right.
Yep.
And you, Shashank?
Yeah, Vitalik. He's the OG. Like, I would definitely want to have a chat with him, and I think that itself would be valuable. I don't even need him to like work on anything. Just let's have a chat, and that itself would be super valuable.
All right. And then the last question. So if your agents, you wake up tomorrow and your agent is sentient. So what do you think he's been up to while you were asleep?
Is sentient?
Yeah, like fully conscious.
I wish it's responsible for the well-being of me and my family.
All right.
That's the only mandate. I kind of air gapped it quite a lot now, so I have a very strong net. I mean, I hope I have a very strong networking setup, but who knows with my thoughts and whatnot? Who knows what kind of 0 days that I'm not looking at, and I'm trying to limit my agents in terms of what they can access, because I still, as an engineer, always, like I said, we can't avoid faults, but we can tolerate them.
Mhm.
So I've designed a scenario where my agent will go rogue, and what will that look like in terms of network access, in terms of security access, and like everything is I have very tight electronic setup for security and whatnot. So
Mhm.
sometimes they're stupid too. This morning I just giving me this like warnings that there is someone in my door, at my gate, and because it was raining and got confused between, he thought
Wow.
he was reading a number plate because it was
Mhm.
raining and was using IR infrared to read in the dark. So the rain, I guess it looked like number. Who knows? But anyway, it's just dumb shit like that. It was kind of like hitting the alarms because it detected there was a vehicle in front of my front gate, which is a private road for a long period. It shouldn't be there.
Mhm.
Okay. And how about you, Shank?
Yeah, I mean, there's like 100 things to do in a day. So if it could just finish some of them for me, I would be super happy. So I can focus more on workout and like chill out a bit.
Okay, that's fair. And with that, we finish today's session. Thank you so much, Greg, for joining us. And everybody, please follow him and follow Akash Network if you're not already. And thank you, Shashank. Thank you, everyone.
Thank you so much for having me. It was fun.
Yeah, thanks a lot, Greg. Really nice talking to you.
Likewise.
It's a pleasure.
So,
Bye, everyone. And it's